All right, guys, today in class, we went over the very beginnings of Chapter P, Section 5, Part C. And we're talking about adding and subtracting rational functions. A rational function is a fraction, all right? Rational is just a grown-up way to say fraction. A lot of us don't love fractions, I know that, but we are going to be dealing with them a lot. They're not going anywhere, so we're going to have to just suck it up and get comfortable with them because fractions are our friends. When we're talking about fractions, guys, remember, the first thing is they have to have a common denominator. And this is going to go back to what you guys did in middle school of adding and subtracting fractions with like and unlike denominators. Same kind of concept, just we're going to have to use a little bit of algebra with our letters, our variables, mixed in here. But you guys can all do it, I promise you. The first thing you're going to have to do, if they have the same denominator, you just go ahead and add and subtract. If they don't, then we have to get a common denominator. So we want to make sure we factor all the denominators first because we want to get the least common denominator, just not any random common denominator. We're going to multiply each term by what's missing from the denominators. Then once we get it to be the same, we're just going to add and subtract numerators. So we're going to do the first part today, and then tomorrow we'll do the second part. You guys have plenty of time to practice tomorrow in class. So the first couple problems are super simple. You guys have seen this a million times. If you were adding 1/2 and 1/3, you can't just put it together because the denominator's not the same. So what would your common denominator be? Well, you would say your common denominator would be one of the denominators, which is 2, times the other denominator, which is 3. When you multiply 2 times 3, you get 6. So your common denominator is 6. So the way that you go about this in your mind, I know you guys can do this, but the way that you would go about this in your mind is say, okay, my first fraction, it has a 2. What would I have to multiply the first fraction by in order to get it to be a 6? Well, you guys would tell me, oh, you have to multiply it by 3. Well, what you do to the bottom, guys, you do to the top. My second fraction I look at, it has a 3. What would I have to multiply that by in order for it to become a 6? Well, you would say 2. So if I multiply the bottom by 2, then I multiply the top by 2. So now you see all 3 of them have the same denominator of 6. So now we focus on the numerators. What is 1 times 3? 3 plus 1 times 2 is 2. And then we simplify. 3 plus 2 is 5. So 5 over 6. Now we're going to carry that same concept throughout the whole process here. So bear with me, all right? If I look at number 2. Number 2 is a little different. You guys would look at this and say, oh, the common denominator is 12, which I agree, but how do you make 12? Well, this is 6 times 1. I can also write 12 as 6 times 2. If you were going to break that down, we'll say. So your common denominator is going to be 12. It's a combination of 6 and 2. So when I say 12, I look at my first fraction and I say, okay, it has the 6. What would I have to multiply this by to make it a 12? You would tell me 2. What you do to the bottom, you do to the top. Perfect. Then I look at my second fraction and I say, what would I have to multiply 12 by to make it a 12? Well, it already has the 6, it already has the 2, so I just leave it alone. It's good to go. Now we deal with, since we all have a same denominator, you notice 6 times 2 is 12 in red, 6 times 2 is 12 in blue, 12 on the bottom, we're good. So now deal with the numerator. 1 times 2 is 2, plus 1 equals 3 over 12. And would we ever leave our number, our fraction, our answer as 3 over 12? No, you always have to simplify, guys. So you would divide the top and bottom by 3, and your answer would be 1 over 4. So the concept is going to be exactly the same on 5 and 6 as we go through here, and I'll do those in a second. But I want to go through, and you guys see some rationals that have actual expressions in the denominator, right? First thing I'm going to tell you guys to do is to put parentheses around your denominators. See if you can factor anything. You can't. But what do you notice here? The denominators are the same. So when your denominator is the same, you just rewrite the denominator and then deal with the numerator. So it's 1 plus 2. 1 plus 2. So I would say 1 plus 2 is 3, and then my denominator is x plus 1. And then you look and see, is there anything in the top and bottom that's exactly the same that you can cancel? No. So there you go. So I look at 4, all right? 4 is a little different. I'm trying to do all of these so you guys can see some things. Put parentheses around your denominator. Very important. See if you can factor anything. Another thing I like to do is when there is a minus sign, I like to change it to a plus and then stick your minus sign right here in front. And I'm going to put these in a parenthesis because what are we going to have to do with that negative sign? At some point, we're going to have to distribute it. So it's a good idea, anytime you see a plus sign, minus sign, change it to a plus, and then stick your negative right in front there. If you have an expression in the numerator, put it in parentheses. So I look here, guys, and I say, oh, wait a second, my denominators of both of these are the same, so I'm just going to leave it as x plus 2. And then we're going to deal with the numerator. So my first numerator is x plus 1. My second one, I'm going to take this negative, and I have to distribute. So it becomes negative, oops, sorry, hold on. Distribute here. So this becomes negative 2x, and then a negative times a negative is a positive 3. If we don't remember to distribute, we're going to get that sign wrong, so it's really important that you guys remember to do that. And now we're just going to combine like terms. I have a 1x and a negative x. Sorry, 1x and negative 2 gives me negative 1x, and then 1 plus 3 gives me 4. And then I have that leftover x plus 2. Is any parenthesis exactly the same? If you wanted to take out that negative, you don't like leading with a negative, you could take out a negative 1 and make this x minus 4 over x plus 2. Those two things mean the same thing, but you don't have to do that, but these are both the same thing. All right, now we come to a problem like 5 and 7. You guys are going to see these more tomorrow, and you're going to see these on your quiz. If you look at your denominators, go ahead and put them in parentheses. They are not the same. They're kind of similar, but they're not exactly the same. So we have to say, okay, how could we get a common denominator? Well, what do they both have? They both have an x, so we can write that down. And what does one have that the other one doesn't? A 6. So I'm going to try to make both of these denominators look the same. So if I look at my first fraction, it has an x. What is it missing? Well, I have to multiply the bottom by 6. Well, if I multiply the bottom by 6, then I multiply the top by 6. I look at my second fraction. It already has a denominator that looks like 6x, so I just leave it alone. So then now, guys, since we have a common denominator, we deal with the numerator. So it's 6 plus 5. And when I add that together, I get 11 over 6x. And there's nothing that cancels out or anything like that, so we just leave it. Then I go over to number 7, and I look and I say, okay, let me put a parenthesis around both of my denominators. I can't factor anything. They're already in simplest form. I see a minus sign, so I'm going to go ahead and change it to a plus and then stick that negative right there so I don't forget. Now I have to find a combination. What could I multiply together that would give me a common denominator between x plus 2 and x minus 4? Well, on our first example we took the 2 and the 3, multiplied and got 6. So we're going to do the exact same thing here. They're both completely different denominators, so I'm just going to write them both down together. I'm going to multiply them together on the bottom. Just like we did in example 1 with 2 times 3, I'm just going to take the denominator of the first one and multiply it to the denominator of the second one. And now we're going to make equivalent fractions. My first fraction already has the x plus 2. What is it missing to make it look like this one? The x minus 4. So what you do to the bottom, guys, you do to the top. My second fraction has the x minus 4. What is it missing so it looks like this? The x plus 2. What you do to the bottom, you do to the top. And now if you look, all three of them have the exact same denominator, so we can go ahead now and combine like terms. We can multiply, we can combine. That's good. So 1 times x is x. 1 times negative 4 is minus 4. Negative 3 times x is minus 3x. And negative 3 times 2 is minus 6. So again, we're going to rewrite our common denominator of x plus 2, x minus 4. Our common denominator just keeps riding with us. And I'm going to combine like terms in my numerator. So x minus 3x is negative 2x. Negative 4 and negative 6 gives me a negative 10. And we always want to see if we can simplify, because the directions say simplify. That means make it the smallest as possible. So is there a GCF? Is there a number or letter that goes into both negative 2x and negative 10? Yes, a negative 2. When I take out that negative 2, I'm left with x plus 5. And then on the bottom, I have x plus 2 and x minus 4. If you guys notice, there's no parentheses that are exactly the same or anything like that, so we are done. So you guys can start your homework. We have homework that's not due until Friday morning. We'll go over a quiz review on Thursday. But I want you guys to start practicing as much as you can, and then we'll finish the section tomorrow with the rest of the notes, and then you guys will have time to work in class.